Here is a combined summary of the two pages. The United Nations Trade and Development, UNCTAD, has developed its own open-source Retrieval Augmented Generation, RAG, large language model, LLM, application, tackling the challenges of generative AI adoption in official statistics and international organizations. Since the release of ChatGPT's GPT 3.5 model in November 2022, LLMs have gained popularity, offering potential benefits in domains such as statistical databases and natural language interaction. However, the costs of adopting proprietary solutions can be high and uncertain, hindering adoption by cost-constrained organizations. To address these challenges, UNCTAD's Global Crisis Response Group, GCRG, has explored and developed an in-house RAG LLM application, making LLMs more useful and aware of the organization's domain and work. This approach offers pros such as cost-effectiveness, flexibility, and fostering institutional knowledge, but also requires significant time and skill investments, potentially resulting in gaps in application polish and power. The application consists of 4 publicly available libraries: NLP pipeline for document processing and statistical analysis, local RAGLM for running a local RAG LLM, Streamlit RAG for the user interface, and local LLM fine-tune for fine-tuning existing LLMs. These libraries are available on PyPI and GitHub, accompanied by Dockerfiles. By developing and sharing these libraries, UNCTAD aims to promote the use of RAG LLMs in official statistics and international organizations. This work highlights the potential of open-source solutions in bridging the gap between generative AI and official statistics, enabling organizations to harness the power of LLMs while mitigating the costs and uncertainties associated with proprietary solutions. The development of in-house solutions also fosters institutional knowledge and flexibility, allowing organizations to tailor LLMs to their specific domains and needs. Large language models, LLMs, have gained significant attention since the release of ChatGPT's GPT 3.5 model in 2022. These artificial neural networks are trained on vast amounts of natural language text, enabling them to predict the next word or series of words based on prior context. The utility of LLMs can be further enhanced by incorporating Retrieval Augmented Generation, RAG, which allows LLMs to be aware of and contextualized on new information. This can provide numerous benefits, including querying against trusted research to synthesize information, generating insights from organizational reports, and providing easier access to statistical databases. RAG offers a solution to the acute shortcoming of LLMs architecture, which is their ignorance of information outside their initial training data. Retraining an LLM daily or weekly with new data is infeasible due to the high computing power and cost required, which can be in the millions of dollars. The growing complexity and parameter count of LLMs will continue to increase the cost of training frontier models, despite decreasing compute costs. The current landscape of LLM services is divided between offerings from large tech companies, such as Google and Microsoft, and open-source LLMs. There are also organizations, like News Research, that focus solely on open-source LLMs. UNCTAD has developed a completely open-source, custom LLM application in-house, navigating the rapidly developing field of LLMs. The journey and experiences of UNCTAD will be analyzed, including the development of their open-source libraries. The pros and cons of open and closed-source LLMs will be evaluated in the context of national statistics offices and international organizations. Future areas of improvement and work will also be examined. The discussion begins by highlighting the limitations of large language models, LLMs, in providing accurate information, particularly due to hallucinations. To address this, the concept of context windows is introduced, which allows for passing new information alongside queries. However, this approach is limited by the size of the context window, which varies by LLM. To overcome this, the RAG approach is presented, which involves chunking and embedding documents or large corpora of text into numerical vectors. These embeddings are then stored in a vector database and can be retrieved using a retriever to provide answers given new context. The key point is that the LLM is not aware of all the information in the vector database but rather uses the retrieved chunks alongside the query to generate responses. This approach is shown to be effective in reducing hallucinations and improving accuracy. The discussion also touches on the limitations of this approach and the current state of proprietary offerings in the field, highlighting Microsoft's Copilot Pro as a user-ready option. The paper discusses the pros and cons of developing generative AI applications in-house versus using external, paid solutions. On the in-house development side, cost is a significant advantage, as it is limited to staff salaries and machine costs. Additionally, there is flexibility in terms of features, allowing for on-demand improvements and customization. However, the paper also highlights the uncertainty and potential risks associated with external services, including pricing volatility and the risk of service discontinuation. It emphasizes the importance of considering these factors when deciding between in-house development and external solutions. The paper concludes by noting the benefits of using open-source software, which offers flexibility and can be updated quickly to incorporate the latest developments. The development of an in-house generative AI tool offers several benefits, including the accumulation of institutional knowledge, fostering of institutional capacity, and enhanced privacy and data control. By creating an in-house solution, organizations can ensure their data is stored securely and only where they want it to be, avoiding potential risks associated with external services. Additionally, in-house development enables the organization to work with generative AI not just as a consumer but also as an active developer, leading to a deeper understanding of the technology and its applications. This understanding can inform UNCTAD's substantive work and expand the guidance it provides to developing countries on the topic. However, there are also significant drawbacks to consider, including the availability of resources and capacity, scalability, polish, and access to frontier models. For instance, in-house development requires staff with the proper skill set, which can be a challenge, especially for organizations in developing countries. Furthermore, handling scaling and ensuring robustness and polish can be difficult without the resources available to large companies. Despite these challenges, the benefits of in-house development make it an attractive option for organizations seeking to leverage generative AI effectively. The development of a comprehensive text analysis and search application by UNCTAD's Global Crisis Response Group, GCRG, is discussed. This application leverages OpenAI's LLM API for its brains and utilizes a local PostgreSQL vector database. The process begins with text corpus processing from various document formats into a format compatible with the embedding model. UNCTAD's library for text processing, including optical character recognition, is used. The application's front end is built with Streamlit, supporting multiple users and persistence of vector databases. This setup allows for LLM-agnostic and embedding model-agnostic usage. The application's components are available on GitHub and PyPI, and Dockerfiles enable easy deployment. It can run on any NVIDIA GPU-enabled machine or Apple Silicon Macs, with CPU support as well. The system supports unlimited simultaneous user sessions, with requests queued for simultaneous generation. The importance of institutional space for innovative projects is highlighted, as this work was carried out without a clear immediate need but has the potential for transformative impact. The application's versatility and the potential for repurposing its components are emphasized. The research paper highlights the potential of generative AI in enhancing the capabilities of national statistical offices, NSOs, and international organizations. It emphasizes the importance of investing in data science capacities and institutional space for innovation to occur, as demonstrated by UNCTAD's experience in developing generative AI applications entirely for free and in-house. This approach allows customization to an organization's specific needs, leveraging open-source community resources. One key area for improvement is fine-tuning an existing large language model, LLM, on a dedicated corpus of raw text, without question and answer pairs, for knowledge and style injection. This can be achieved using the local LLM fine-tune library, which utilizes the UNCTAD package to enable local fine-tuning. Fine-tuning can make the LLM more suitable for a particular task or domain of interest, enhancing its performance in various applications. Another avenue of improvement involves optimizing the existing RAG system, such as fine-tuning or improving the embedding model and vector search functions. This could ensure that the most relevant and helpful text chunks are passed to the LLM for answers. Hyperparameters can also be optimized, such as researching which chunk sizes, chunk overlap values, context window sizes, etc. produce the most helpful answers for different use cases. Introducing pre-filtering steps to the vector database may also be beneficial, such as pre-filtering documents by year before the search, to increase the likelihood of returning relevant and useful chunks for the LLM. The rollout, adoption, and training of these AI systems are crucial steps for any new data product, especially for LLMs due to their natural language responses that can appear omniscient and confident. Users must understand how they work and their limitations and follow correct validation guidelines to avoid hallucinations and wrong information. RAG helps with this issue, as it returns alongside its answers both the actual texts it is basing its answer off in addition to the metadata for those texts, making it relatively easy to verify if a fact or figure the LLM returns is not contained in the source texts, likely a hallucination. Still, this requires training and awareness for end users. In conclusion, generative AI offers much promise for NSOs and international organizations, similar to the private sector. With the proper investment in data science capacity and institutional space, it is possible to develop generative AI applications entirely for free and in-house, customized to an organization's specific needs. The best solution likely combines both fine-tuning and RAG approaches, using RAG on a fine-tuned LLM. The development of a language model for UNCTAD's data processing pipeline is not a binary choice between paid and free services. The infrastructure and institutional knowledge acquired during this process can be leveraged to introduce paid components into the pipeline or switch to a completely managed solution in the future. For instance, the LLM could be changed from local open source to an OpenAI API call, releasing the requirement for hosting on a GPU-equipped machine, addressing scale, and giving access to frontier models while continuing to not incur costs for the vector database or embedding model. The development of in-house skills increases flexibility. The experience and contributions made by UNCTAD to the vibrant open-source community around generative AI with the tools developed aim to lower the barrier to entry for NSOs and international organizations in developing their own solutions. This underscores the importance of collaboration and knowledge sharing within the research community to advance the use of AI technologies in various sectors. In terms of methodology, the paper outlines the process of fine-tuning pre-trained language models on domain-specific datasets, which significantly improves their performance in downstream tasks. The use of a hybrid approach combining both traditional and AI-based methods for data extraction and classification demonstrates the potential for synergy between different methodologies. The paper also highlights the importance of data quality and the need for continuous improvement in data collection and processing. It emphasizes the role of human judgment in validating the output of AI models, particularly in contexts where accuracy is critical. The figures and tables provided in the paper illustrate the performance of the language model in different tasks, showcasing its capabilities and limitations. These visual aids help in understanding the efficacy of the model and areas for further improvement. Overall, the paper presents a comprehensive overview of the development and implementation of a language model for data processing at UNCTAD, emphasizing the potential for AI technologies to enhance data extraction and classification processes. It highlights the importance of collaboration, knowledge sharing, and continuous improvement in data quality to ensure the accuracy and reliability of AI models.